We will go ahead and get those presented. Okay, we can now see that we're live streaming. So with that, let's turn the time over to Rob. So thank you, Rob.
Excellent. Let me click the screen share button and share. Pull chat back up. Excellent. Can you see my screen?
Yes.
Perfect. I'm so glad we get to dig into local development techniques with Kubernetes. A lot of times when we start looking at Kubernetes or containers, Docker at all, we kind of consider that a downstream concern. I'll just let them do the containery bits. And so this presentation is really focused on what can I do in the midst of my development process to be able to leverage containers? Because sometimes it's actually easier to debug inside the container than waiting for it to flow downstream, see if that works. So let's dig in. Here's the part where I tell you I am definitely going to post the slides on my site tonight. In this talk, though, there are no slides. This is it. That's the only slide. The things are up on this GitHub gist. This is kind of an outline of all the things that we're going to look at today. So you can click into all of the different software that we'll look at, which is really cool. This gist is available on this really painful URL, but head off to robrich.org, robrich.org, click on presentations, and here's local development techniques with Kubernetes. You can dig in straight here to get back to that GitHub gist. While we're here on robrich.org, let's click on About Me and we'll see some of the things that I've done recently. Thanks for the intro. Here's Microsoft and Docker giving me some awards. I'm a friend of Redgate, and AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Salt Lake, hit me up during the meetup or grab me on one of the socials, and let's get a Give Camp here in your neighborhood too. Some of the other things that I've done, I run the Utah County.NET user group, and I also run a user group in Gilbert, Arizona. I'm not sure how long I'll be able to continue that one, but I've gotten to do a whole lot with .NET and with Docker, so we'll dig in deep there today. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comments in the air, and they sent me a mug. So there's my claim to fame. And if you'd like a .NET Rock, no, I'm just kidding. Richard Campbell is awesome, though. Cool. So let's dig into some interesting things here in Kubernetes. Well, we're going to take a look at starting easier, running differently, visualizing, rebuilding faster, visualizing container contents, visualizing cluster contents, and finally debugging inside of containers, which will be really fun. So I've got this Docker file, and in this case, this Docker file runs this Node app, but it could just as easily run a .NET app. And so now I want to build it. So I come here on the command line and I say Docker build. I need a dot apparently, -t, hello, node v0.1. Oh, wait, the dot goes here, not over here. Okay, is that all the command line arguments? Okay, well, now that I've built it, now I need to Docker run this. Hello, node v0.1. Oh, wait, I need a -p for some reason. Let's say 3000 to 3000. Oh, wait, that doesn't go here. That goes over here. -p 3000, 3000. Wait, do I need a dot at the end? Oh, wait, no, I don't. And I just spent a whole lot of mental energy just trying to build and run this image where I probably lost focus on the task that I was trying to do. Instead, we can just say Docker compose up. Nope, not you. Docker compose up. Now, when we say Docker compose up, it will do all of those steps. Here's my Docker compose file. Now this says there's the dot, hello node, the version, the 3000, 3000. Oh, I totally forgot about setting this environment variable. Now that I've got that started, we can come over here to the browser and go to localhost 3000, and we get our website. That was really cool. And just as easily as we started it, Docker compose down, and now it stops. Now you may have used Docker compose in the past, and if so, that was nothing new. But one thing that I'll point out here is network mode of bridge. Now, a lot of times when we start a Docker compose project, it will spin up a new virtual network. So if we wanted two different Docker compose files, maybe one for our backend and one for our database. So if we were debugging our front end, we'd start them both. If we were debugging our backend, we'd just start the data stores. By using network mode of bridge, it doesn't create that virtual network, and now we can communicate between all of our containers. On the upside, we can communicate between all our containers. On the downside, it doesn't automatically create these DNS entries. So we might instead want to say network my app, and then here in networks, my app driver of bridge, and we'll just put that in all of the places. And then we can communicate, and it creates the DNS entry. Let me set that one back. So that was starting easier. We don't need to do all the cognitive load of figuring out all the build and run commands. We can just say Docker compose up, and it'll do what it needs to do.
Okay, so could I ask some questions for clarification, just in case people don't all have background here? Okay, so you talked about DNS entries. So I presume what you're saying is Docker, like Kubernetes, has the idea that DNS, you start a pod, and now, or I should say, you start a container. That container is now available to the other ones that are also running via that host name that you gave it. Is that correct?
Yeah, exactly. So
Okay.
this is Docker mode. So this is just running a container, but I might say something like DB. And then here I would say image is, it's going to give me Mongo. And so now if this container wants to connect to this container, then it just says curl HTTP DB 27017, or if I'm setting a connection string, I would say server equals DB, port equals and now I've connected to that other one. Similarly, I might have another API. And so, yeah, I would have API, and maybe that would build in the API folder, and the ports there would be 3000 to 3000, except for this one's already on 3000. So this one, I'm going to map through my router to 4000. So now outside the container, I would go to localhost 4000, but inside the container, I would go to API/3000. Yeah, these names right here in Docker will automatically create DNS entries so that I can connect to other containers.
Okay.
That was a great question. Cool. So let's talk, actually, any other questions right here before we dig in?
So you could run multiple Docker compose files at once and they don't interact?
Right. I can say Docker compose up, and I can give it a file, Docker compose backend.yaml, and I'll put it in daemon mode or detached mode. And that will start that one. And then I can say Docker compose up -f Docker compose store a database.yaml. And now those two things can start to discover each other. Or actually, in this case, I'm going to presume that those YAML files don't have this network mode setting, and therefore they can't interact with each other. They're just two completely isolated networks.
Yes. So to summarize, Docker has the idea of networks, and depending on the configuration that you give, those networks can be isolated or they can be shared, therefore allowing discovery and interaction.
Right.
Okay.
Let me go find a picture that describes this really
Looks like-
nicely.
So Wayne's raising his hand literally on camera. So Wayne, did you have a question?
Ooh.
Yeah, question for you. Can you launch Docker on multiple machines at the same time? Because I have a process, I'm doing some massive unit testing that can't be done realistically on one computer in a reasonable amount of time.
You definitely can run Docker across many machines. And what's really cool is you can say just Docker run on each one, or you can submit this job into a cluster. An orchestrator can then distribute it across the machines, whichever ones are available. And so one example of an orchestrator is Kubernetes, but we could also look at Azure Service Fabric or AWS Fargate. Those are all different orchestrators that would allow us to just say, hey, can you run 5 of these? And it will kick off all 5 in different ways.
You mentioned Kubernetes. You mentioned Kubernetes. That's all I need to know from this point, because you'll cover my question then.
Oh, perfect. The way I like to explain Docker networks is that we have a router at home. We might have a router in our office. And on the WAN side, then we can think of this as localhost. And on the LAN side, this is inside the Docker network. Then we have each of these containers and they're launched on different ports. And here we can say, okay, we're going to map some ports across from the WAN side to the LAN side to be able to hit at these different containers. That's why from out here, I just call this localhost 3000 and localhost 4000. But for each other, they actually have to specify their names or their IP addresses to be able to communicate. Cool. So Docker Desktop is definitely the easy button. And if I want to be able to run Kubernetes locally, I can just pop open the settings. I go into the Kubernetes, I click the Enable Kubernetes button, and then I have Kubernetes. Docker is definitely the easy button, but I often get asked the question, well, where are the files that I stored in that volume? And so I have to do things like WSL list -v, and I say, see that Docker desktop data? It's in there somewhere. And it's this kind of viscous concern where people are like, yeah, but where? So let me show you Minikube. And Minikube is an open source project that allows us to be able to run Docker and Kubernetes inside of a virtual machine. Now we can configure it with various virtual machines. So we might use VirtualBox, or I'm on Windows, so I'm going to use Hyper-V. And so I have this Minikube virtual machine right here. Now, in this case, I actually have some other Minikube virtual machines as well that have different demos in different ways. But I can just then come in here and I can say Minikube start, and I could pass in other parameters, and then up pops that VM. Now, I've already started it, so I can say Minikube IP, and this is the IP address of that thing. Now, unlike Docker Desktop, Minikube doesn't automatically mount localhost and map ports and volumes, so I need to do that myself. So in this case, I've chosen to mount this particular folder into that VM as this particular folder, and you'll actually notice as well that when I went here, I didn't actually go to localhost, rather I went to minikube colon something. So we kind of have to do that ourselves. Now that's okay. But one of the things that's really cool about minikube is it is the batteries included internals exposed version. So when people ask me when they're using minikube, hey, how do I get at the volumes? I can say minikube SSH, and now I'm actually in that virtual machine. Docker Desktop doesn't let you remote into it. And now I can sudo su. So yeah, I'm running as administrator now. And then I can come into var lib docker. And when they ask me, hey, where's my files? They are in there. So I happen to have one volume here called VS Code. And here's the files that I have inside that volume. Now, the cool thing about that is I can go poke at it. It's the batteries included internals exposed version. And so I can be able to interact with it in really interesting ways. Now, I do have to wire it up into Docker. So I'm going to say minikube docker env, and it's going to spit out the environment variables that I need to be able to set in my shell so that when I run Docker commands, it's not going against Docker Desktop, but rather against minikube. So I'll just go grab these environment variables, I'll set them in my shell. And now when I say Docker image list or Docker container list, I get all of the details. Now this is the internals exposed version. So if I say Docker container list, it's actually going to show me all of the Kubernetes containers. Now, if I go into the Docker settings, I could choose to turn those on or off. They're off by default. But here in minikube, they're on by default. So I might say Docker container list, but I will pipe that to grep-v k8s to hide all of the Kubernetes containers. Now I'm just looking at mine. But the cool part here about this minikube docker env is you notice that it spit out PowerShell variables. If I were to start this up in a command prompt, it would print out command prompt variables. Or if I were to start it on Mac or Linux, it would do bash environment variables. And so it's really good at noticing the shell that you have. And so then I just run minikube docker env, pipe it to invoke expression, and now I get the environment variables that I need to be able to set. Now, the cool part is I can set those settings here inside of VS Code as well. So let's come in here to open my settings. And I just set that Docker environment to match that IP address of minikube. And that lights up all of my Docker and Kubernetes extensions so that they'll work inside of VS Code as well. Anywhere else where I need to be able to use Docker, I can just set these 3 environment variables there, and that will launch nicely. So minikube. Docker Desktop is definitely the easy button. And so if you're just trying to get started with Docker or Kubernetes, it's definitely the best way to go. But if you want to peel the onion a little bit, then minikube can be a great alternate runtime that gives you a little bit more power and a little bit more flexibility. For example, minikube add-ons list. Here's a list of add-ons where I can just choose to turn it on. I don't need to, for example, go wander around for YAML to be able to start the metric server. I just say here, hey, I would like to run the metric server. And so I turn it on. And now the metric server is available here in my Kubernetes cluster. And I didn't need to futz with stuff. If I wanted to do ingress or Istio or any of the other things that I'm looking for that they've provided here, I just turn on that add-on and that feature is available in my cluster. Any thoughts on minikube?
Looks pretty neat. So just let's see if I'm summarizing correctly here. Docker is one of many tools that implements an API that runs containers, right? So there's containerd, there is minikube. I don't know if it's using containerd or something else behind the scenes, but there are various engines that can all run containers. And what you've talked about so far is Docker and Minikube as two different implementations of those.
Exactly. There is an OCI, an Open Container Initiative standard, and there are lots of tools that can build OCI compliant images. And there are lots of tools that can run OCI compliant images. Docker Desktop is one of those tools that you can use to build them. And Minikube is another one. Docker Desktop can also run them. So can Kubernetes and lots of other tools. And so as long as you're building and running OCI compliant images, you can mix and match the tools to be able to match the needs that you have.
Okay, thank you.
Didn't you have a graphic that showed Docker and how that fits on a machine in one of your presentations that you were flipping through?
Yeah, there's this graphic that I'll often, that's not it. This graphic that I'll often show, comparing virtual machines to Docker. Docker virtualizes the operating system compared to virtual machines that virtualize the hardware. So when we're virtualizing the hardware, we need in each virtual machine. In Docker, because we're virtualizing the operating system, we don't need a duplicate copy of our guest OS. So this is definitely not to scale. But we saw here, we only got 3 virtual machines using up all of our hardware. Here we got 7 containers to be able to use that same hardware. We're using our hardware more efficiently because we don't have so many layers of indirection. We're choosing to virtualize at a higher layer.
The downside is you have to use the same OS on all of them.
Right. The OS of my container needs to be the same as the OS of my host. And so Linux containers need to run on a Linux host, and Windows containers need to run on a Windows server host.
Now, isn't it true that some of the orchestrators like Kubernetes, they allow you to have hosts of both varieties that you can kind of intermix with or distribute workloads to?
Yeah, exactly. So I can have nodes, I can have machines in my cluster that are Windows machines. I can also have machines that are Linux machines. And when I schedule a workload, I can say, hey, I've got a workload. Can you just make it run where it runs? And Kubernetes will figure out where it needs to start and start it correctly, either on a Linux or a Windows machine. So the next tool that I want to show is Docker Watch. Now, I would love to be able to say Docker Watch, go watch my code, and if anything changes, go rebuild it. By comparison, I can say .NET Watch, and it will go do the thing. So I'll say .NET Watch run, and then anytime my code changes, it will rerun my application, which is cool. I can do a similar thing to say npm start -- watch or npm run watch if I want to start nodemon to do interesting things. But if I come here to Docker, I can say Docker watch. Nope, that's not actually a command. I wish it was. And the cool thing is Docker Compose actually has an experimental feature now that allows us to be able to watch. But let me show you Scaffold. And what's really cool about Scaffold is Scaffold can watch a directory, rebuild an image, optionally push it to a container registry, and then start that job inside of Kubernetes. So let's come here and switch to the right folder. And now here in this folder, I will say Scaffold dev, and we'll see that it will go find that Docker file. It will start this Kubernetes YAML file, and it'll do that automatically, watching all the files in this directory to see when things change. Okay, so it just built that image. Perfect. Now I'm going to pop this image inside of VS Code. So let's close this and this and this and come here into this directory. And right now it says hello world. Let's pull up the node port that this is running on. It is 3200. So now it says hello world, and I don't want it to say hello world. I want it to say hello slc.net. Now I'm just going to push save, Control S, and we notice that Scaffold automatically notices that change. It's going to rebuild that image. It's going to optionally push that to my container registry and start it up. Now I've got a lot going on my machine, so if I can hurry, then I might be able to see the other one coming down. Yep, it's terminating. If I wasn't also Zoom sharing, then maybe it might have terminated before I got there. Let me give it a nudge and see if it'll terminate there. Is it gone? Yep, it's gone. So now I can just push refresh, and maybe I have a meta refresh set in my browser, and now we've got that change automatically set in my app. I just come in here and I change this. And it automatically rebuilds, automatically pushes to my container registry, automatically starts my new version. This is, in effect, Docker Watch, which is pretty cool. Let me stop that.
Okay, quick
Cool.
question.
That was really, go ahead.
Yeah, so I noticed you pulled up the kube control, or some people call it kubectl, as a command. So you kind of switched from a Docker context to Kubernetes context. What does Scaffold work at? Is it working at the Docker level? Is it working at the Kubernetes level, or is it defined in the YAML file?
It's actually specifically working at the Kubernetes level in this case. And I believe you can actually rig it to a Docker Compose file as well. But I'm specifically saying use kubectl to deploy this Kubernetes YAML file. And so it will build this image and then start that Kubernetes YAML file.
Okay.
Okay, next up, I want to be able to visualize the contents of my cluster. So let's say dive hello node, and it'll take a second to come up. And so let's take a look at what is Dive. Dive is an open source project, as with all of the projects we'll look at today, and it's a great way to be able to visualize the contents of the container. So I've got this container that's maybe too big, or it's awkward. I kind of want to take a look at it. Now I can come in here and I can say Docker history hello node, and that will show me each of the commands that were run and the size of that layer. But what's in that layer? I don't know. And that's where Dive is really helpful. So we've got Dive, and it will optionally pull this from our container registry. And we can now take a look at the layers. So I'm going to close this folder and this folder, this folder, and this folder, and this folder. Let's also close this folder. And now I will start to navigate through the layers with the arrow keys. So I'm going to go down one. Here's the next layer. Oh, that's where NPM starts getting put in. Now we're adding yarn to this app. That's pretty cool. These are all in the base layers of the image that I chose to use. Here in my Docker file, I start off by saying from node Alpine. So those are all of the things inside of node Alpine. Here's where my image starts. Workdir app. So there's the app folder that got created. Then I'm going to copy all the files. Oh, hey, it copied the Docker file and the Docker Compose file. I definitely don't want that. I might have libraries in the wrong directory. I might have copied too much. Well, yeah, let's come back here to our app and let's see if we can solve that. Oh, it looks like I forgot a Docker ignore file. So let's create a Docker ignore file, and I'll ignore bin and obj, and I'll ignore star.user and .env. And in this case, I'll also ignore Docker file and Docker compose.yaml. And if I still had scaffold running, it would notice that there was a new file, rebuild my image, and I could go take a look at it again. But we've stopped scaffold. And so we can now wander through the layers of our image, taking a look at the content that got added at each layer. We can take a look at the sizes of things, the image ID, and that can be a great way to be able to visualize the contents of our image if we only have a command line to do that. If we want to do it more visually, then we can take a look at Whaler. So let me start up my, that isn't it. That's not it. Oh, I'm in the wrong folder, that's why. Now I can start up Whaler. Whaler is a Python app. And so let's say Whaler image equals hello node. And Whaler is a really cool open source tool that allows us to be able to look at the contents of our image visually. And so it starts up a web server. Let's hit that web server and we'll take a look at localhost 8080 and we'll cruise through this image. Did it not start? There we go. Now, in this case, my image is pretty boring. It only has those 3 files, but I can really quickly visually see the weight of each of the files in the file system and get a feel for when I might have bottlenecks. Now, Whaler is really cool, and we've got this visualization. So let's actually take a look at their the visualization of their image. So I'll start up this URL that is that example Whaler file. And now I can take a look at all of the files inside that image. Well, if I wanted to reduce the size of this image, going after this file is probably not going to help me very much. This one probably won't help me either. But if I went after this file, I could definitely make an indent in the size of my image. And this file would be another one to see if I can prune. And we can see lots of different groups of files in here. So maybe we could trim this entire group to be able to make some progress. With Dive, we got to see this visualization from the command line. With Whaler, we get to see this visualization from a website. And it allows us to be able to tune our app to be able to look at things in a really elegant way to be able to visualize the contents of our image. By comparison, if we just say Docker image list, then I've got this image, but all I know about it is it was built 6 minutes ago and it's 180 megs. What's in there? That's where Dive and Whaler can come in really handy. Any questions here on Dive or Whaler?
So this is more a question out of my curiosity. So let's say that one of those base layers has a large file, right? Now, if maybe I'm incorrect, I did some investigations into the layers and stuff a while ago. It seems like every layer is basically just union FS'd, or effectively the newer, or yeah, I'll just say the later layers are unioned right on top of the prior layers and take precedence. So in theory, we can remove it, but does the size actually get smaller when we delete it at one of the lower layers?
Good question. And you're right, all of these layers get unioned together. Here's the visualization that I like to show, and this is definitely an oversimplification. But in our first layer, let's add file 3 and file 4. In our next layer, let's add file 2. In our next layer, let's add file 1. Let's delete file 3, and let's change file 4. When I start up my container, I see file 1, file 2, I have no file 3, and I have the changed file 4. But each of these layers are atomic. So this container is going to have that unified file system that shows me the results of this. But file 3 still exists in this tree, and the original file 4 also still exists. So my container doesn't get smaller if I delete things. So rather, I need to not add file 3 back here to be able to get this container to be smaller.
So so both Dive and Whaler are excellent tools for understanding the content, but if, let's say, file 3 was included in Alpine and we don't want it, our only other option would be to look for or to customize the base image that we're using to build on top of.
Right.
At least.
Yeah, we want to pick a base
knowledge,
image that has just enough to help us, but not too much, because that might be that might make our image larger than we expected.
Okay, cool. Thanks.
Yeah. So we took a look at how we look at our, go ahead.
So does that graphic tool only work with Docker images, or can you use it on, I mean, even just a host machine or any machine?
You can use it on any OCI compliant image on any machine.
So what does OCI mean?
Open Container Initiative. It's the format that Docker images get built into.
I see. But things like Windows and stuff don't follow that.
Right.
Okay, thanks.
Yeah.
I will point out, though, there is a tool in Linux called QDirstat, in Windows called WinDirstat, that does present the file usage in that same visual, right? So you get the blocks that indicate size and give you a quick way to drill into it. Those tools also allow you to delete and do other things. So
very nice.
Yeah, so there are good tools that will do that on your own OS as well.
Next, let's take a look at how we might visualize our cluster, all of the containers running in it. Now we're going to start in Docker mode. Here is Lazy Docker, and Lazy Docker is a great open source project. We did Whaler. Here's Lazy Docker that allows us to be able to visualize all of the containers running in our cluster. And the cool thing is, unless we're using the Windows command prompt, we can actually click through it in the terminal. So here's all of the containers that are running, and I can pick this container. Let's take a look at etcd, and we can actually see the console logs here. We can take a look at the stats. So yeah, a live graph in a terminal. I think that's amazing. Here's the environment variables that were set as part of it, the config that we've got in that container. We can also take a look at the images. So here's the Hello Node image that we just built. No, actually, this one has a different tag. There it is. Here's the image that we just built and all of the layers and all of the things. We can also take a look at volumes and the mount point. So that's the URL that I want, a Minikube. And we can also take a look at the various pieces of our cluster. So if I can only SSH into the machine, maybe my Raspberry Pi, this is a great way to be able to visualize the Docker side of the cluster. Now, if we want to do this through a web browser, we can take a look at Portainer. So let's do a Docker. Let's actually get to 5. Docker compose up. Now, Portainer is a really cool way to be able to visualize this from a browser. And Portainer is great at looking at the Docker side of things. It can also do the Kubernetes side, but I would argue it's not as good. So now that we've got that started, let's head over to localhost, or in this case, because I'm on Minikube 9000. And now we are looking at Portainer. Now, the hardest part of this is creating a password. And they recently made it 12 characters long. Now we can take a look at our environments. So we could run on remote clusters and connect to it that way. But in this case, I'm going to take a look at the cluster that Portainer is currently running on, my local cluster. We can see that we've got 37 images, 2 volumes, 24 containers. Let's take a look at those containers. Here's all those containers that are running. And in fact, we can see the Portainer dashboard container right here. And so we can take a look at each of the things. Let's actually start a new container. I'm going to create my container from the hello node image. And I'll publish some ports. I want to map 3000 to 3000. And I'm going to deploy my container. Now, the cool part is that I was able to take a look at start my container. So here's the container that we started. It's Festive Wilson, and it was based on that node image. We can take a look at the console logs. So there's the console logs that we started. We can also go take a look at the inspect. If you've ever done a Docker inspect, and it's just barfed all kinds of things, that's interesting, but I really like being able to navigate through here where we can take a look at the particular things. If you've ever looked for the IP address on a container, it's really nice to be able to open it up here rather than Docker inspect and then pipe that to grep and go. This is a really elegant way to do that. And the cool thing is I can now come in here and attached to the console. This is an Alpine-based image, so I'm going to start with Ash instead of Bash. And now I've exec'd into that container. So one of the things that's really interesting is I'm like, well, the container didn't start correctly. Why is that? Oh, because I'm not starting in the directory where things are. I'm still in my source directory. I'm not in my bin directory. And I could even say node server, which would start that back up. And of course, port 3000 is in use because, well, the container is running. But I can now wander around and cat server.js, and there's the app that I chose to start. When I'm done, I hit exit. And so if I only have browser access to my cluster, I can still exec into the things. Now that we've done that, let's remove this container. And now this container is no longer running in my cluster. Now we noticed that we did log into this when we began, which is really cool. So let's also come in here and log out. So that was the Docker side of things. Now let's take a look at the Kubernetes side of things. Docker compose down, and we'll stop Portainer. Now I'm going to start up K9s or K9s. This is an open source project for being able to look at Kubernetes clusters. And the cool part is it has VI bindings. So if you're familiar with VI or Vim, then you can just wander through here. So I'm going to take a look at the default cluster. Let's go to, I hit colon, and I'm going to look at services. And here's the services running in my cluster. And I want to look at a particular service. Let's look at the kubedns service. Here are the pods running inside that point to that service. Now that I have that, I can take a look at the logs for these. And I can navigate really quickly because, well, I'm using VI commands. I'll escape out of that, back up to the top, or I can hit colon and go into pods. And now I'm only looking at all the pods in my cluster. I'm going to hit colon Q to exit out. And now I'm back out of K9s. Next, let's take a look at Schooner. So I'm going to say kubectl apply -f Schooner. And let's take a look at what is Schooner. Schooner formerly was K8-, and it's a great way to be able to visualize a Kubernetes cluster. Now, Kubernetes does have a built-in dashboard, but it doesn't have authentication built in. And so once we get this started, let's go find the port that was on, kubectl get all, and it looks like it's on port 32,000. So let's come here into Minikube 32,000. And now I need to log in. Yes, we can add authentication to the built-in Kubernetes dashboard, but usually we don't. And that can be a real problem. Ask Tesla, where they accidentally left their Kubernetes dashboard open and they became a crypto mine. So let me log in using a Kubernetes secret here, and that will allow me to log into Schooner. And now I can take a look at the nodes in my cluster, and we can see that this is Minikube and it only has one node. We can also take a look at the namespaces. Here's all the namespaces that I have. Default, we have the various pods in this namespace. So let's go look at those pods. Looks like I have one pod, the Schooner pod. Yep. One of the things that's really cool is I like to come in here and take a look at storage and volumes. It's really easy to accidentally forget a volume, and I like being able to visualize it in this way. The other thing I really like looking at is secrets, because secrets can get stale and abandoned as well. Here's the Schooner secret. I'm in the default namespace, but I could switch to all namespaces. Here in the default namespace, though, this is the secret that I use to log in. Schooner's methodology is if you have access to the cluster enough to be able to get at the secret, then you have access to be able to get at the Schooner dashboard, which is really cool. I don't mind showing this because I'm only running this locally, but I love that they hide it by default, which is really cool. I'm going to come in here to profile and log out, and now we're logged out of Schooner. The Kubernetes dashboard, the Schooner dashboard, similarly to Portainer, allows you to be able to create new content as well. So if I were to come into pods, I could, oh, actually, no, Schooner, yep, create a new pod and apply that. So like Portainer, like Schooner, like Kubernetes dashboard, you do want to secure this correctly. But the cool part was we were able to then look at visualizing the Docker side from the command line, visualizing the Docker side from a UI, visualizing the Kubernetes side from a dashboard, from a command line, and visualizing the Kubernetes side from the from a UI as well. Let's take Schooner down. Any questions on Schooner or K9s or Portainer or Lazy Docker?
So when you created a container in Portainer, did it create a compose file for that setting, or is it saved in the Portainer settings?
It is not. It would be much like if I said Docker run hello node, it just runs that thing.
Okay, so it's not persistent. Okay, thank you.
Right. You bring up an interesting point, though. I probably want to create the YAML, either the Docker compose file or the Kubernetes YAML file, so that when I start it up, it's reproducible. If I just go into the UI and click buttons, then that content is not very durable. If the cluster gets reset and I need to restart the thing, I have to then click the buttons again.
So do any of those tools allow you to like export? Like say we just manually got it up and running and stuff, and then say, oh, okay, let's export the current configuration so we have it.
All of them allow, both Portainer and Schooner allow you to take a look at the Schooner allows you to take a look at the YAML that created it, and kubectl does as well. But as you start a thing inside of Kubernetes, it adds a lot of extra properties. So if I were to say kubectl apply Schooner, here in my YAML file, we have a deployment and we have a service. But if we were to say kubectl describe service Schooner, we see that there's a lot more properties set on it. There are a bunch of things that we chose not to set in our YAML file because the defaults were acceptable. If we were to export this either through kubectl or through Schooner then we would get all those extra things, including runtime values that we probably don't want in our original thing. And so it's intriguing to say, well, how about I just click the buttons and export it and that becomes my YAML? I would rather not. I like where you're going though. Let's switch this from plain text to YAML. And I have here this extension that this Kubernetes extension, not that one, Kubernetes extension from Microsoft. And the cool part about this Kubernetes extension is it allows me to scaffold stuff really easily. So I'm going to say, I want to scaffold a deployment, and I made sure that my file type is YAML. And there's a deployment. So I'm going to say, this is hello node, and it just set all of those things. What's my image? Hello node v0.1. Now, I, in this case, do want to say replicas to 3. I want 3 instances of it. I might tweak the resource limits. I do need to set my container port to 3000, but that is a Kubernetes YAML that I created in, say, nothing. Let's do it again with a service. Hello node. And the selector, here's the details that I had there. So I'll do similar things here. And I'll map port 3000 to port 3000. I can do a similar thing with an ingress and fill out all the details there. And so I find scaffolding YAML files for Kubernetes here really simple now that I have that Kubernetes extension.
Nice.
Yeah, it's really cool. Now, next up, let's take a look at debugging a container. Now, here in this folder, I have a .devcontainer.json, a dev container folder. And inside there, a dev container JSON file. And so let's start up a new instance of that in code. And it takes a little bit for this to pop up. So I'll start it up and then let's take a look at what this does. But one of the things it'll notice, hey, you've got this dev container folder, you've got a dev container JSON file in it. So, hey, how about I just start this up in a container? Oh, it looks like it's going to do it automatically. That's cool. Oh, no, there we go. Hey, would you like to reopen this in a container? Why, yes, I would. So what did we do there? Well, VS Code actually splits itself in half. I've got my local VS Code that includes all of the details of themes and colors and font choices. I have my source code here on my local machine. But then I also have a container that runs the other half of VS Code. Now here I have all my language extensions and all of my linting and building tools, and it has a volume map into my source code. So VS Code connects to the container and maps that volume into place. And so I now have VS Code running inside of my container. Now, taking a step back, how do I get started with that? I've started with the extension I called dev container. I got the dev containers extension installed. The cool part is it's part of this remote development extension pack. And so you could use this with WSL, you could use this with dev containers, you could use this with SSH. So if you have a Raspberry Pi and you're like, I'm tired of changing this file and then SSHing it over into the Pi just to notice that it isn't right yet, you can use this remote SSH extension and use VS Code with your files on the Pi. And so you're just editing and saving from your local machine, and it just pushes that over and does the thing. So once I've got that dev containers extension installed, I restart VS Code, and then I come in here to the 2 triangles, and I can say, I would like to create a dev container. And it'll give me lots of samples that I can play with in lots of languages and cultures to be able to just have a good sample of playing with this. Once I decide, hey, I've got this project that I want to run and I want to add the content here, I can come back in here and I can say, add dev container configuration files. And then it will scaffold out those .dev container folder and dev container JSON file within it. And so then once I've got that, then I can come in here and I can say reopen in container. And now it will launch VS Code in that split brain mode to be able to interact with my content inside the container. So we've got this here. Let's create a new terminal. And if we say uname -a, yep, this is real live Linux. I'm running inside this container. And if we come back here to our command line and we say Docker container list, and I will filter out the Kubernetes control plane, there's that container that is running inside my cluster doing this VS Code stuff. Okay, let's pop open our dev container JSON file. Oh, actually, let's pop open our source code first. Now, one of the things that I like to do as I'm building my source code is I want to set breakpoints and I want to run stuff. So let's come here into my run and debug, and I will start it. And now it's going to launch on port 3000. We can see that it's starting up right here. It's loading on port 3000. And hey, it says, hey, you've got this port open. Would you like to open it in a browser? Yes, please. And let me show you the URL here. It is actually running localhost 3000, not minikube 3000. It automatically created that secure tunnel. So if I can only get to my cluster and launch it, even Kubernetes, even Azure, and I want to be able to debug it, I can do this exact same process from there. Now, the page isn't loading up. Well, that's because VS Code is stopped right here. Now I can take a look at the variables. Let's take a look at the incoming URL. URL is / in this case. I can take a look at other variables. The status code is already set at 200. My response headers are already set. That's just a proxy off to this thing. So I can take a look at the various content in my request and response. I'm going to push go, and it's going to launch again. Why did it launch a second time? Well, it's now coming in to grab my favicon.ico. So I'll take my breakpoint off and I'll push go, and we can see that the page rendered. Perfect. I can now use this to be able to debug my content running inside the container rather than having to wait for the next build. And then I can actually take a look at variables and do interesting things. I'm going to hit stop.
So a question.
Now let's take a look. Yep.
So is the code just mapping to your host machine, or is the code being copied to the container?
The code is actually on my host machine. So let me change this to SL.
It's just a share kind of thing.
It is. I'll go back to my original VS Code running on my local machine, and we can see that it's there.
And so the advantage of that is if you accidentally forget something, you don't put your code on the Docker, right? It doesn't actually.
Yeah, I'm not
reside there.
changing this container. I'm just changing my source code on my local machine and debugging it within the container.
Cool.
Now, is it using a sidecar container to like run the dev container stuff? So it's running in the same pod. Does it just do some magic with the Docker file? So it's just a single container, but all of the dev container components are present?
It's just a single container, just a dev container. And so let's take a look at how we set that up to look at exactly that. I set here the base image that I want to run, or in this case, I said, I want to run Docker file. Now, this Docker file is not the Docker file that I use in production, but rather a different Docker file that I'm going to use to debug it. And this just says from node Alpine. I added curl and git in case I want to do some source control stuff here. And then I set my workspace directory. But do you notice that we didn't do any copy? We didn't do any run commands, because all we want to do is get that source code into place. Now that I've got my source code in place, the post create command, this is where I would do a .NET restore, maybe a .NET build. And in this case, I did an npm install. So it'll go look through my package JSON, notice that there are no things, and get all my node modules in place. I can also set up some extensions that I want installed in this container, some VS Code settings here, and then I can specify ports. Now, we noticed that it discovered it automatically, which was really cool, but I'm specifically identifying the ports as well. Oh, it looks like it wants host and port now instead. Now, because I'm running inside of Minikube, I not only need to do this process, but I also need to be able to configure this to know how to launch it. So we saw when we first started up, we said Minikube, Docker, env. How do we set those things in place? Well, I went in here to VS Code and I opened up my preferences and I set my Docker environment so that VS Code knew how to connect to Minikube. But then in my project, I also, just in case, wanted to set these settings here if they only apply locally instead. So now that I've set my settings, I also need to map my thing. Now, if I was using Docker Desktop, I wouldn't need to do this, but I'm using Minikube, so I need to map my local folder into a folder inside that virtual machine. And so then here inside my dev container, I say, oh, and by the way, here's that folder where you got the stuff. It's not the folder that you're thinking of on the host machine, but map that into the workspace folder. And that workspace folder happened to match the folder I mentioned in my Docker file. So if I wasn't using this in Minikube, then my dev container would look like that, and that would be completely fine. And so the cool part, I can specify exactly what I want inside this dev container in running inside of my local cluster. I could choose to add curl or SSH or various debugging tools. I can also choose to add some extensions. And the cool part is if I come here into the extension editor, so let's pretend I want the C# extension here, I can come in here and say install in dev container. And as part of doing that, it'll prompt me to say, oh, by the way, would you like me to update the dev container JSON to mention that container, that extension as well? And so we get this really elegant way of being able to capture all of the details that I need inside my container to be able to do all of this stuff. Here's where the runtime is running. Here's where .NET is running. In this case, it's Node. Here's where all my theme and UI things are running. In the same way that we do this with LiveShare, we can do this now with dev containers. So here's my font, here's my color choices, and here is my language extensions, my IntelliSense, my Python packages, all of that is running inside the container. And yeah, it's just a container inside my cluster. Any questions here or thoughts on dev containers?
Pretty cool.
Yeah. Ooh, open lens. Yes. I really like lens as well. So now that I'm done here, I will close remote connection. And now it just goes back to a regular VS Code where it's not the split brain piece. It's just one VS Code thing using local folders. So let's close that down. Now we got to see a lot of different tools here, taking a look at how we might use containers differently. We started easier, we ran differently with Minikube. We could definitely use Docker Desktop instead. We rebuild faster. I wish there was a Docker watch command, but scaffold is a great way to do that in Kubernetes mode. We used Dive to be able to visualize the content. We also used Whaler to be able to visualize it. We took a look at visualizing our cluster with Lazy Docker and Portainer, both in Docker mode, K9s and Schooner in Kubernetes mode. And then we took a look at VS Code remoting. So all of the details of all the tools together with links to those projects are here in this GitHub gist. And the URL to that, let me set that in chat, is right here. Oh, shame on me for not opening the window wide enough. But you can definitely get to this a lot easier. Head over to robrich.org and click on presentations, and you can get straight there. If you're watching this on demand, hit me up on Twitter at rob_rich or on Mastodon, or head over to my site and click all the social links. And for those here live in the event, what are your thoughts? What tools do you really enjoy when you're playing with containers? Ooh, yes, presenter feedback. And it looks like that's also the URL for prizes. Excellent.
Yes, it is. Yep, feedback, providing feedback gives us, or I should say, it gives you an entry into the prizes for today.
Ooh. Do I
So-
get the car?
What was that?
Do I win the car?
We'll see. What are the prizes? I have a couple of slides that will cover prizes. It is typically, and it is today, O'Reilly for a couple of ebooks and JetBrains subscriptions. So I'll cover that, but if there's any questions, now is your last chance, I guess, to really to ask them. If there's tools you like, I've used K9s, I've used OpenLens. I haven't seen a bunch of these, so learned a bunch of new things.
One of the questions I often get here is, so should I use all of them? No, I used a lot of tools that looked at different things in different ways. And so find the tools that make you happy, that facilitate your workload, and start to leverage those. You probably won't need all of them. You probably will use only a few of them, or maybe your existing tool chain is sufficient. But what I've hopefully done is help you to kind of peel back the onion so that containers aren't just a thing that happens downstream, but rather something you can really embrace in the midst of your development experience too.
Yeah. So what are, so this is slightly off from the topic, but I think it's directly related. And that is, where do you find you get the most development from using containers in your development process?
Ooh, let me give you one example that was actually really, really helpful. I was building a bunch of code samples in various languages, and I had .NET installed on my machine, but I needed to build a Node example, a Ruby example, a Java example, a Python example, and I didn't want to install all of these different runtimes. And so I created a dev container with that particular framework for each of these things. I built up my sample. I could debug it. I could validate it works correctly. Once I got it working correctly, then I just saved off that sample, and I didn't need to fill my box full of all kinds of interesting goo. Another great example is if you've ever tried to help somebody install SQL Server. Okay, no, one more option down. No, go. Hit back. Okay, I can just create a Docker Compose file that installs the SQL Server Linux container. And then as I start up my work, I can just have SQL Server there. And I didn't need to futz with trying to get it installed locally. Those are both great use cases for using containers as I'm doing development. SQL Server is a little bit heavy, but Postgres and Mongo and Redis are all great data stores. So if your project uses those, avoid the install locally and just use them inside of containers. Even if you're debugging from inside of VS Code or Visual Studio, you can still use those data stores as if they were local data stores. They just aren't. They're a container.
Yep. Great examples. So one of the things that we've been working on is being able to take, in our case, it's Istio, but to use Istio to redirect traffic to, I'll say, certain versions of a system, right? So say, I have this old version, it's rock solid. I'm developing a new version, but I don't want to necessarily, test, or I should say, I don't necessarily want to push it out to everybody, right? So I can use a container. I can route traffic to my main instance that's running in my development environment, but then I can still use the local one on my local machine for development purposes, or I can do like A/B testing or canaries. So there's tons of stuff that you can do. It just takes some knowledge.
S. Shaw asks, have you ever used containers in a DevOps environment, such as build agents, post-build automated deployment, integration testing? Let me show you this repo. This repo is based on a talk where the answer is, how do I web test my SPA with various things? And so the premise of the talk is, well, what type of unit tests would you do? And I pull up this page with a list of all the JavaScript tools to test various things in various places. So, Supertest and Axios and Test Utils and Karma and Mocha and Jest. And somebody asked me once, hey, can you build all of them? And so that's exactly what this repo is. Now, as part of this repo, I have a GitHub workflow that will go run all of those tests. So here's npm test running all those things. But one of the dependencies inside of this project is Redis. And so here in my API, it actually connects to Redis to do interesting things. Why Redis? It was there. But I'm going to try and connect to that Redis based on these environment variables. And so in the middle of doing these integration tests, I need to be able to spin up Redis. Well, if I'm using it locally, yeah, I just do a Docker compose up. I've got Redis available and I can do all the things. I'm actually mapping a volume here to ensure that this data is a little bit more durable. But how do I get that to work inside this build? Well, the cool part is I've got all of my steps doing all the things, but I started up with this service here where I said, hey, can you launch Redis? Launch this Redis container and map these ports into the agent. Then when I'm going to run this, let me set these environment variables to localhost and this port. And now it uses that Redis build container in the midst of this build. And so I spin up that container, I do all my integration tests, I validate that this works as expected. And then as soon as I'm done, I spin that back down, harvest my test results. And so if we come in here to the builds, we can take a look at the test report and we can see, yep, all of my unit and integration tests passed because it spun up Redis as part of that build. Such a great question, Shaw.
Yeah, we've done very similarly, not quite as elegant, with just a PowerShell script where it started up a couple of Docker containers. It did like a Docker inspect. And I think we used like JQ or a JSON path or something to pull the, the IP, out of that. So it was just dynamically assigned an IP and a port. We didn't ever have to worry about conflicts. And then we were able to use that just to stand up the whole SQL server and everything as a part of the pipeline.
Yeah, I've done similar things here where I just say, hey, can you build and run this container in the middle of my DevOps pipeline?
Yep.
Question. Can you tie this into code coverage? Because a lot of developers these days write their unit test based on after they write their code. Back in the old days, we'd have two different teams, like in the telecom industry, we have two different teams, one that wrote unit tests, one that actually wrote code. And so I don't want my build to be successful or DevOps to deploy to from dev to testing unless I have complete code coverage. Do we have anything like that that can tie into like a DevOps capability of building my unit test? But if I don't have my my unit test built to cover my code, it can't deploy. Am I clear? Am I clear as mud?
Yeah. How do we kick off our code coverage as part of our unit test and then validate those code coverage metrics and fail the build if they don't pass?
Because I see too much code out there that they just write their test to meet their code, and they don't write their test up front like that you should.
In the Node community, there's NYC that wraps Istanbul that can do exactly that. So I can say, hey, go run my code coverage on my front end. And based on the metrics that I've set here, where's the metrics? Right here, fail the build if they don't meet those criteria. And so I can say, hey, I need 80% code coverage. And if you don't get 80% code coverage, the build fails. NCover was the de facto standard inside of the .NET world for the longest time. They have since gone closed source. And so now there's a plethora of similar tools that you can use to harvest code coverage and then use that to either succeed or fail the build.
Okay.
Coverlet. Ooh, that one sounds like a cool thing.
We use Coverlet. It works very well. If you're ever interested in assembly rewriting, it's a fun example. It actually takes the assemblies, it parses them with mono-CECL. It adds instrumentation to grab the coverage information, and it writes it out to file and stuff like that. So it's pretty cool.
Cool.
Can I
So
ask
it's not
an unrelated question?
Code.NET thing. It's actually rewriting the assembly.
Well, actually, it's IL, right? So
yeah.
Can I ask an unrelated question?
Definitely.
Hey, I'm writing a .NET plugin right now for Visual Studio and for SQL Server Management Studio that is more of an AI intelligent editor for SQL. I am looking for no data, just structure, tables, functions, stored procedures, stuff like that. Just the code aspect of large databases. We're talking about databases that are more than 1,000 tables, more than 10,000 stored procedures. If anyone can give me one of those, I'd be appreciative for testing. Because what I have is you have a person's table. It might relate to managers, employees, spouses, children, whatever. So I can go from manager, and it'll actually do my replacement on the IntelliSense and say it'll actually join the right table, and then tells you on when you do your inner join what tables you can join that table to or the tables from. So doing stuff like someone changes the gender field to put, or zip code. Let's use zip code because it's less politically affected. Someone puts a Z in the zip code column. How did that Z get in? Or an O, 84, 105 or whatever. Someone puts an O instead of a 0. How did that get modified? Well, I can tell you in 20,000 stored procedures exactly what stored procedures that can be modified. So it's a great tool for speeding up debugging or bringing a new developer up to speed. So I'm looking for large databases that are I can test with, but I'm not looking for any data. I don't want to know users. I don't want security. I'm just looking for code, tables, function names, views, including bad databases. Anyone has one they can send me, please do so. Okay, I'm not going to pirate it or anything like that. I'm just using them for testing case purposes.
That sounds brilliant.
Sounds like we have something that might be worth presenting later.
I've offered and I've been told basically the group's not interested. The board's not interested.
So,
but I can literally, I'm creating an app right now that will create a random database with multiple databases. So if you have table A that's in one database, but it might be called from 3 or 4 different other databases, I can go across databases and servers using SQL Server with linked servers. So if I can tell you something Ben Miller asked me about, and so I modified my tool to do what he's wanting, but I'm creating random databases, but I'm not getting real names. I'm creating fake names for table names.
Cool.
So I'm creating.
That's awesome that you can track dependencies that way.
Well, we've had too many developers in the past that are new coming on board that know nothing, or beginning developers that have a hard time learning a database. I want to cut that time down. I want to make a senior developer knowledgeable of the database without having to dig through 25, 50, or 100,000 stored procedures.
Yeah.
So
that's pretty cool.
So
I agree. I
Yep.
for that as in an upcoming meetup. Let's definitely
there
get you on the
is,
schedule and see if you can present the tool.
so there's a link that was shared to kaggle.com. So Kaggle, if I remember right, they do all sorts of machine learning and stuff like that. They have data sets apparently. So maybe there's something good in there. I haven't looked at it, but
because the worldwide importers and VentureWorks and all this, they're too small. I'm looking for something, because a lot of big databases I've worked on might have 2,000 tables and 20, 30, 50,000 stored procs over the years. And so, so every time you make, I got a DDL that gets a DDL trigger in a database. So when you make a modification, it learns as the developers are coding. So if you're doing something, I can learn from what you're doing in real time.
The cool thing about Kaggle is it's great for data sets that allow you to do data sciencey things. But I'm noticing that these are CSVs, so it might take a smidge of work to get from here to a data store. But I've seen similar things where they have interesting data sets that that you could just destroy the data and dig in. I like it.
Well, like I said, I don't want to see data because of there's always there's always stuff in there that shouldn't get out. But if someone has especially data sets, I worked on one data set recently that had in list, and I have like 1, 2, 4, 5, and 9, and it would be that list is used in 50,000, or 500 stored procedures. Well, that should be a table, okay? That should be where you can join it. And so it's finding a lot of errors like that. A lot of the stuff that SQL Server DBAs hate developers, .NET developers doing.
That's not it. There it is. Redgate makes a free tool called SQL Search, and I use this to do similar things.
Not even the same league as what that does. I'm in Ben been talking to me for years about this, and Kevin Klein, who is out there in Nashville. I used to be part of his SQL Server group when I was living in Nashville. This is beyond what I've seen out there in any tool.
Yeah, I like that you're tracking dependencies. Yeah. The cool thing that I like about SQL Search is that I can just type a name and it will show me all of the store procedures and tables and things that have that name, but it's not tracking dependencies. It's just doing a text match. So I'm really intrigued. The other thing that's really intriguing about your content that would make a great presentation is the Visual Studio SDK, building a Visual Studio extension. I think that's quite an intriguing concept as well.
Well, the one
It
thing I
gets
want is
intense.
if you modify a zip code and you put that O in there, because back in my early days in my career, keyboards had the numbers 1 to 10, but typewriters didn't have a 0 or didn't have a 1 key because they were the 1
Right.
and the O. So we had a lot of typos with that. And so say you have that 0, my zip code down in Texas is 78550. Someone put a 78550, the letter O. Well, that can only be modified in the database from an insert or an update statement. If that table might be used everywhere, but that insert or update statement might be used in a finite deal, but that zip code might be updated in only a fraction of those. So I want to know what code I can.
Provided that you're not using inline SQL with an ORM like Entity Framework or Dapper. You might have
framework sucks. It produces
doing inline SQL, then it could have come from a lot of other places. But if you've got a repository pattern around your data access, then you can audit your repositories to see which ones are updating that field as well.
Well, and the issue that is that now if I press on that and I look at it, I can bring up that code and scroll through that code in real time. So I can actually look at the example because the SQL compiler in the Microsoft.SQLserver.management.smo actually gives you in the parser actually gives you the line number and the column in the position. So I can actually go down there and grab it and highlight it immediately with the code without having so it really makes it nice. So it's a great, powerful way of, it's not going to take someone that's an expert with the database and turn them into, a god, but it can take a new developer that might be a senior level developer and bring them up to a knowledgeable database person in
that's cool.
In
I can't wait to see the talk.
weeks.
Yep. So we're starting to run a little long.
Sorry.
So it does sound like